Hello and welcome back to our channel. In our previous video, we talked about basic tools for beginners and how you can use breadboard to construct a simple electronic circuit. In case you missed those videos, kindly click the link in the description and watch our previous videos. If you haven't subscribed for this channel, kindly like our videos and also subscribe for the channel. In this video, we are going to talk about basic electronics component, how you can measure them, and their applications in electronic circuit. The first component on our agenda is a resistor. What is resistor and why is resistor so important in electronic circuit? So, a resistor is basically an electronic component that limit or regulate the flow of current in an electric circuit or provide a voltage drop between points in a circuit. So now that you know what a resistor is, how do you tell the value of a resistor? A resistor basically is, the value of a resistor is basically represented by 4 color bands. And these colors are chosen from 9 standard colors. The process of reading values from colors in resistance calculation is called color coding. There are types of resistors. A resistor can be a variable resistor like this, or it can be a fixed value resistor like this. So what's the difference? A fixed value resistor, the resistance does not change, is fixed. While a variable resistor, the resistance value can be varied depending on to meet the circuit condition or depending on what you intend to use that resistor for. So in essence, resistor is basically like a brake in your car or a shock absorber in your car. So the next component on our agenda is the transistor. So what is transistor? A transistor basically is a 3-terminal device, but more than that, it's an electronic switch. It has the same purpose and function like your tap in your bathroom or in your kitchen. So you regulate the flow of water using tap by on it off or off just by turning the tap. So also a transistor has 3 terminals, namely the base, the collector, and the emitter. You can control the behavior of a transistor by sending a signal through the base, just like you do for your tap. You turn it on and off, depending on the position of the valve. So transistor is basically a switch. So you can use it in electronic circuit to control signals. You can use it in amplifiers to amplify your voltage, and so many things you can use a transistor for. There are 2 types of transistor. In this case, I'm going to limit my conversation on bipolar junction transistor, known as the BJT. So we have 2 types of BJT. A transistor can either be PNP or NPN transistor. So the next component on our agenda is the diode. So basically, diode play a significant role in electronics. It allows signal to flow in one direction, and that behavior has been explored in converting AC to DC in your rectification unit. So a typical diode like this one is IN4001. It has anode and cathode. So we'll go into detailed description of what anode and cathode, or how you can identify and measure the characteristics of a diode. The next component is a capacitor. A capacitor basically stores electrical charges in a circuit. So it's a 2-terminal device. You use it in a circuit to either filter out AC ripples in a DC, especially in power supplies, or you can use it in an amplifier to block DC component from AC component. It has so many applications in electronic circuit, and we have polarized and non-polarized. The one I'm holding is a polarized capacitor, which means it has a positive and negative. While we have a non-polarized capacitor like this, is called a ceramic capacitor. It doesn't have a polarity, so you can put it in the circuit without minding the polarity. It doesn't have negative or positive. That's what it means by non-polarized capacitor. We have other few things you need, though they are not basic component, but they are important in electronics, basic electronics. So we have LED. You use it as an output device to create a visual indication of circuit state or circuit condition. We have also a buzzer. This one provides a sound output like a kind of beep. If you want, it's nice to add it to your electronic project. So I'll show you how to measure and also calculate the resistance value of a resistor. So we have two symbols to represent a resistor in a circuit. You can either use this symbol or this symbol. There are 10 colors used in resistance calculation. So we have black, brown, red, orange, yellow, green, blue, violet, gray, and white. And each of these color has a value assigned to it. So black has 0, a brown has 1, and so on and so forth. So let me show you the simplest way to calculate a resistance value. So let me just write it. You can write it like the first color value second color value times 10 raised to power the third color value. So let me briefly explain what I meant by that using an example. So in this resistor we have orange, brown, then the tolerance value at the end. So I will explain the tolerance value after this example. So our first color is what? Is orange, which orange is 3. So our second value is what? Is still orange, and the value of orange is 3. So you write 3 times 10. The third color here is brown. So the value of brown, the value assigned to brown color is 1. So you can now write raised to power of 1, which is equals to 3. 10 raised to power of 1 is still 10. So you can either say times 10, which is equals to 330. So the resistance value is 330 ohm. So let's take another example. Let me choose a different resistor. This resistor has red, brown as a color. So similarly, we can apply this formula. The first color is red, and the value assigned to red is 2. So we have 2. The second color is still red, and the value assigned to red is 2. So we'll write 2. Then the third color is brown. So brown is 1. So we can write power 1, which is equals to 2 times 10, which is equals to 220 ohm. So the value is 220 ohm. So we can Also try another one. So this is another resistor. So in this case we have brown. So let me make use of this page. We have brown, and the value assigned to brown is 1. So we have 1. Then the second color is black, and the value assigned to black is 0. So we'll put 0 times. The third color is red. So we'll put times 10. We have red, and the red is what? 2. So that's the value of the third color as the power. So the red is 2. So we can say 10 times 100. So 10 times 100 is actually 1000. So it's equals to 1000 ohm. So it's 1000 ohm. So you can now you can now say 1 kilo ohm, because it's 1000 kilo. 1000 or 10 raised to the power of 3 is equals to 1000 is equals to 1 kilo ohm. So you can use the unit of resistance is ohm. So kilo ohm, mega ohm, depending on the magnitude of the resistor. So this is how you can calculate the value of a resistor. So let me show you how to measure the resistance value using digital multimeter. So this is auto range. Don't forget that Fluke did not sponsor this video. So it's auto range. So you take your ammeter. This one we calculated as 1 kilo ohm. So let's see what the meter will give us. So we have 0.98 kilo ohm. So approximately 1 kilo ohm. So this is where you apply the tolerance depending on the color, if it is silver or gold. So the tolerance can be 10% or 5%. Majorly you can see silver or gold as a tolerance value. So this is where the tolerance is applied. So it's 1 kilo ohm theoretically. So you can have tolerance of either 5% or 10%, as the case may be. So this one we calculated as 220 ohm resistor. So let's measure it. So you can actually measure. So you can see is 213.6 ohm, which is if you apply the tolerance value, is still within the range of 220 ohms. So this resistor, we calculated the value as 330 ohms. So if you use your digital multimeter and check, you can see it's around, this one is 324.3 ohms. So applying the tolerance value, you can see that this resistor is still within the range of 330 ohm. So this is how you theoretically calculate the value of a resistor using colors, and also you can use digital multimeter to measure the resistance. So if you are dealing with circuit, it's advisable to remove the resistor out of the circuit before measuring it, so that you can be able to tell the value of that resistor. So if you got any value from this video, kindly like this video and also subscribe if you haven't subscribed.